So now let's try to do this when we're not given a picture, right? So we can also find the slope of a line segment if we have coordinates by using our fancy slope formula where y equal, oh wait, not y, not y. Their slope equals y2 minus y1 over x2 minus x1. Or this is basically saying the y value of a point minus the y value of another point minus the x value of a point minus the x value of another point. By the way, we are already in the spot where the beginning of a formula sheet is coming together. The first part of your 30-3 formula sheet is just the slope formulas. So you will have in your test basically slope formulas and how you do a linear relation. So that's one part of it. The other part is just rise and fall. So here, if I was to label this, I'd call this like x1, y1. I'd call this x2, y2. Right? It's like the first point is the 1, the second point is the 2. Oh, that's weird. That's okay. So now we'll write out the formula first. M equals y2 minus y1 over x2 minus x1. No, I don't expect you to write the whole formula every time. It's fine if you sub in. But so in this case, it's like 6 minus 2. 6 minus 2 over 8 minus 5. Or I end up with 4 over 3. You can leave it like that. That's perfectly fine slope. But most people probably would prefer either mixed fraction or a number. So you could call this either 1.3 repeating, or you could call this 1 and 1/3. Either of those are fine. The slope is that. Let's get rid of this. It's the same value. Notice here also the value is positive because the numerator is positive. The way we've set this up, going from left to right, will always mean that the bottom is positive, right? As long as you're working from left to right, the bottom will be positive. It's just a question of whether it's moving up or down. So we've got a case here where we may end up with something different. So our slope is m equals y2 minus y1 over x2 minus x1. This time I'm just going to substitute in. So here's y2, here's y1. So 2 minus 9. That looks like a negative. Over x2 minus x1. So that's 3 minus 1. So I have a value of negative 7 over 2. Now, negative 7 over 2 is perfectly true, right? That is the answer. But if I said to you, hey, what's negative 7 over 2? Most of you are going to look at me like, so I think it'd be nice if instead of use a number you recognize, if I convert this to a decimal, or a mixed fraction, or if I just say, put this in the calculator, see what you get, it's going to tell you this is equal to negative 3.5. Right? And I suspect most of us are more comfortable with negative 3.5 than we are with negative 7 over 2. And that's part of why, yes, this is true, and this is much better. One of the strands of math in your, in the syllabus, if I pull up your mathematics curriculum, and I go to the front matter and read what it says. One of the points talks about communication, effective communication in math. And one of the things I think that is often missed, especially among students who are in Dash 3, although this is true in general in high school, is just what's the best thing to say, right? I'm hoping for most of you that next year you're not doing math course. I hope next year you guys are working at some random job, getting some experience. And I suspect that your boss isn't going to care so much if you can do a bunch of work on a page. But they probably will care if you're able to communicate pretty effectively, and if you're able to do the things you need to in that context. So most of the time, it's what's useful to use here. So negative 7 over 2 is the same thing as negative 3.5. That's true. But I sure don't want to tell the average person, oh, that's 7 over 2. I want to say 3.5. It's just what makes sense to say. Does that make sense, or am I talking? Oh, thank you. Okay, I'm talking to 2 students and great. How about this one? DE. Okay, so if I call this x1, y1, call this x2, y2, and I say that m is y2 minus y1 over x2 minus x1, okay, now I've got negatives in the values. So I'm at a point in quadrant 3 and a point in quadrant 4. Let's negative 4 minus negative 3. Uh-oh. subtracting negatives, that sounds painful. And then I've got 1 minus. We remember our integers rules? Maybe? I'm starting from -4 and taking away -3. Or starting at -4 and I'm adding 3. This is now -1. And if I'm taking 1 and I'm taking away -1, I do find subtracting negatives, for me, it helps to think about money. The reference I use, I always say that, C students go like, don't do that. But I think of negative money as debt. So I have $1 and then I take away $1 of debt. So right, I had $1, but I also owed Ryan $1, but now I don't owe her $1. So now I'm like, basically having $2, right? Kind of, sort of. Or a sort of more maybe understandable example. I had to pay to get our septic tank drain. It's like, the poop sucks. But my dad paid for it, so he paid it. So I was sort of in debt to him. So it was like I had the money I had, but then my actual value is once I paid my dad back. That's what I did. Right? So today I e-transferred my dad's money. Now it's okay. Now I've got all my accounts set. Anyways, so 1 minus -1, that's 2. This is the same as 1+1, which is something most of you know. So this is -1/2 or -0.5, same thing. I'm perfectly happy with you saying either of these. They're both simple, both easy to understand. Now, today is a day where for most of you, you have more time to work than you probably. That's fine. I would like you to do each of the questions on this one. I don't think it's going to take you half an hour. I'd like you to work through all of the practice. If you're really stuck on something, you can ask me to help you. Or you can go to the answer and okay. The only one that I suspect is going to take you a bit of time is number 2. Basically. Yes, I do definitely recommend work with someone else. Feel free to be social. Most people in this class are nice, except the ones who aren't.